Good morning, ladies and gentlemen. It's a real pleasure to be here. I think we better get started fast because I have about 60 slides and 50 of them are about Creax. So don't worry, it's the opposite. I will briefly introduce, of course, the company. And we are quite active in chemistry and chemistry-related industries and activities. And I hope I will be able to inspire you and maybe give you some interesting findings of how we approach technological innovation and R&D, let's say, and mainly how people can benefit from cross-industry learning. So, okay, brief introduction about the company, but the majority will be to inspire you, as I said, about a methodology, a structured way of generating ideas and benefit from cross-industry learning. Actually, at Creax, we feel like this guy here, you probably recognize the ship of Christopher Columbus. Why is that? Because, as you all know, Christopher Columbus discovered the Americas, but the Americas were not new. They were already existing, but when he discovered them, they were new. That's exactly the same what we do or try to do with technology, with ideas, with solutions, that we believe that every problem has already been solved by someone, right? So we try to identify who in the world has faced similar challenges as yours, how have these been solved, and can we actually transfer, again, technology, solutions, across industries in order to reinvent the wheel, what we experience on a daily basis and continuously happens within companies. Now, how we want to do this is to combine two, let's say, sometimes opposite worlds. We try to combine creativity with research. So what we exactly do, again, I won't go too much into detail, but in fact we work on three pillars. We help companies, first of all, to anticipate for the future. That's mainly our science and technology intelligence activities. We help them to create, we help them to develop new products, new technologies, help to solve technological challenge, and very often also in the chemistry or in chemical areas, we help companies to identify new markets, new applications for their existing processes and existing products and technologies again. And then finally, of course, as we want to make innovation tangible, we help them to validate and to implement the solutions and bring them to market. Okay. As you can see, these are some client references, and we are active in very various industries. Why? Because what we try to do, the model that we have is that, okay, all of you, you're specialized, and your colleagues, you're specialized in certain areas and on certain technologies, and you're the experts in that domain, and you have a lot of knowledge, of course, in your domain. But again, there's lots of knowledge outside your own domain, and how can we make a match? And that's exactly the insight that we try to provide. It's like it reminds me of a quote I had from a client, being Goodyear, and the tire company, that once told us, the reason why we work with your approach with Creax is that you don't smell rubber yet. Meaning that if they have a problem, they look into the rubber industry, they look at Michelin, Bridgestone or others, whereas our role is really to come with that external insight. And also, what becomes very important is that open innovation network. I sometimes say, as a joke, that we become more and more a dating site for companies, but that's actually the case. And I'll have a nice example later on in the presentation. So we have a very nice job. Okay, now the basic philosophy that we apply in our approach is that functions stay, but the solutions change, right? And that's exactly what innovation is all about. It's about finding better, more efficient solutions for the functions that you want to achieve. I compare it with, let's say, in sport, for example, high jumping. You, until a couple of years ago, before my time, and probably before your time as well, people used to have this kind of technique, and the scissor-like technique to actually jump as high as possible. Okay, but suddenly there were no longer new world records. So people tried to think, okay, how can we better achieve this function by maybe apply another technique? And you all know this guy, Mr. Fosbury, from the famous Fosbury flip, that actually found another solution to better achieve the function of jumping as high as possible, right? So the function of jumping as high as possible stayed, but the solutions changed, and we got new world records again. So it's very important to think in functions and not in solutions. For example, people will always want to communicate. People always, in the past, have always wanted to communicate on long distance. We still want it today, and we still will want it tomorrow, right? But people used to communicate with smoke signals or with the tam-tam, later on fixed telephone lines, now the mobile/smartphone. Well, tomorrow it will be something else, right? You can be sure of that. The solution will change again, but the function remains being communication. And of course, this applies in any industry, in any sector. For example, if you look at the detergent business, and there are certainly some players here active, or players here in the conference today, you can look at, okay, what actually do people want? Do people want clean clothes, or do people want detergents, right? Because actually, the function is we will always want to have clean clothes, but not necessarily with detergents, right? So the function is clean clothes. The solution today is detergents, but this evolves, of course, and new, sometimes disruptive technologies pop up. Like, I don't know if you're aware, but electronic companies like LG, Sanyo, and others are actually investing and already bringing zero detergent washing machines on the market, which actually apply new technologies to clean clothes without using detergents, right? Okay, so it's very important to think in functions. If the companies that survive on the long term really think in functions, not in solutions. I think it also, when you mentioned the name of DSM, which used to be a mining company, it's no longer a mining company because it has always been thinking in functions and changing the activities of the company. Now, another important, as I already mentioned, another important thing in which we believe, which we are convinced, is that every problem has already been solved by someone, somewhere. And can you name me a company which you identify as being very innovative or one of their innovative products? What company you think of? Apple. Always number one. Thank you. That was also the answer I was looking for. Why do I mention Apple? Because I have this very interesting quote of Steve Jobs, and you can actually see him and hear him saying this on YouTube, where he quotes. Does it work? That would be nice. But that's not the quote of Steve Jobs. Anyway. Oh, security alert. That because it's Creax. Okay, anyway, we'll get back to the slide. But you can actually see and hear Steve Jobs saying, good artists copy, great artists steal. We, /Apple, have always been shameless about stealing great ideas. So he was really convinced of that open innovation model, even this quote was stolen because I think it was for Da Vinci. When you look at, for example, the iPhone, the first iPhone, it was really a nice innovation, let's say. But if you look at the iPhone itself, it was a new product. But inside there was no new technology. It's about bringing existing things to something new, and that's where new things come from. In our opinion, new innovations come from either transferring from one domain to a completely different domain, or by combining existing things to something new. Okay? So what is important? Nowadays we live in that so-called knowledge economy, and to have an efficient innovation process, R&D process, it is very important to match your internal domain-specific, industry-specific knowledge with that external knowledge. And of course, the challenge is, how can we do so? Okay, let's try a brainstorm. I need a glass of water, yes, but maybe with some water in. But because it's very thirsty. Thank you. That's enough. Okay, we have a challenge. We have a glass of water, and I ask you, how can you get the water out of the glass without touching the glass? How can you do so? Excuse me?
You can put other things in there.
You can put something else in, yes?
Use a straw.
Use a straw.
Heat it.
Heat it.
Put it in a vacuum chamber.
Put it in a vacuum chamber, yes? 4.
Create an earthquake.
Yes, why not? Yes, 5. We once went, excuse me?
In the sun, let it evaporate.
Yes, heating has been mentioned. Yeah. We once got to 20, so if we get to 21 today, I'll play in champagne at the end of the day. You cannot touch the glass.
No, you can crush the glass.
Ah, crush the glass, yes. Yeah, somebody told me once I will invite my mother-in-law and I'll have her sing and the glass will break. It's a bit comparable. Anyway, thank you for your contribution. But what we simulated here was the classical brainstorm. We have a certain challenge. We collect or we invite the specialists in the room, and we try to find, and we will find solutions to solve this problem. But in the same time, we are actually, let's say, limited. Although we are all very smart people, but at the same time, we are limited to the knowledge of all of us here in the room. Okay, so what we have to do is to actually look and brainstorm with the entire world, because and how can we actually do so? It's by going in abstract. Our specific challenge here was to get water out of a glass. But in abstract, what is again the function? What is the function that we want to achieve? In this case, we want to move a liquid. But we are not the first persons in the world or the first companies in the world that want to move liquids, right? So we actually look again in technology, by doing research, etc., in patents, in scientific literature, on the web, how many technologies nowadays exist to move liquids. And in this case, for example, you would find, excuse me, about 45 solutions, technologies to move liquids. And so this really helps to reinvent the wheel, as I call it. And it really accelerates the innovation process because, again, somebody else already solved your problem. Now, that's the philosophy behind it. In practice, how do we realize this? When we are working on a certain technology or product or process, we'll always start from what we call the technology DNA. Now, what is the technology DNA? It's a set of specific properties and specific functions of your technology or your product. Now, again, if we stay with the glass, we have a glass over here, and we want to innovate this glass. We want to develop a new, better glass. How can we do so? We'll start again. We won't talk about a glass, but we'll talk about an object which has the following DNA. It's something which is hollow, which is transparent, rigid, conical, which has a flat surface, which has a certain shape to put it on the table, etc., etc. So we'll describe it in such a way that you will tell me, yeah, Matthew, you're talking about a glass. Okay? Now, these properties are not just there for any reason. They are there for specific reasons. Why is a glass hollow? Because it has to contain something. Why is it watertight? Because the liquid has to stay in. Yeah. Why is it conical? Maybe to stack, etc., etc. Why is it transparent? To see what's in there or how much is left. So it's always this interaction which is very important between properties and functions. And in my conviction, why we are so active also in chemistry and chemistry-related areas is because certainly your industry thinks that way. Everybody, in fact, thinks that way. So if, for example, I'm not sponsored, but I took this example of DuPont. If you look at, and probably on all of your websites and the product sheets on your websites, what you see is that people actually talk about properties of their specific. It's not about Tyvek, no, it's about the specific properties this material has. Because these specific properties gives you applications, right? So in this case, for example, the Tyvek, Sorry. If you look then at possible applications, this material, because it has these specific set of properties, is used for building, for the building industry, apparel, for packaging, for graphics, etc. So it's all about properties and functions. Now, and what is interesting when you start from what we define as being the technology DNA is that you have two interesting directions for innovation and R&D. The first one is that you can look for analogies. Who else in the world talks about similar properties? Who talks about similar functions? And what do they know that we don't know yet? And maybe we can transfer some of the knowledge. I've seen one of your on the slides the rice and the rice bags. We did an innovation study on rice bags for developing better, more efficient rice bags. You know, these little bags that you need to boil for 10 minutes. What is a product which is very analog, which also goes into a little bag, which also goes into hot water, etc.? Tea. So to find ideas, to find technologies to better evacuate the water out of the bag, etc., we analyzed the whole tea industry, or the tea bag in the area, to see what is known by tea bag, which is not known yet by rice bag, and can be transferred. Okay? And it can be vice versa. It can be tech pull, but it can also be tech push. What do you know that others don't know yet, and where can you make a difference that way? I'll give some more examples. So that's the first example, or direction is analogy. The second interesting direction for innovation and R&D is actually what is the difference between your product of today and your product of tomorrow? It's one or more of its properties that you changed, that you modified, that offers you either new functions and or maybe achieve better the functions that your clients needs or that your end user needs. All right? It's not more complicated than that. So these are just some simple general examples of how you can apply this variation way of thinking for product development. For example, it's nearly winter, and might need, depending on where you're living, the classical metal snow chains. Now, if you look at this solution, for example, it's a metal solution. So one of its properties is that it's a solid material. Okay. So can we, question mark, change that property? Could we eventually develop liquid snow chains and change the property state going from solid to liquid? And you'll guess that the answer is yes. So this is a product which is now already also in the market. And that was the first generation. And it's a kind of liquid that you put onto the tire. It becomes immediately a hard foam, and it gives you the function grip on slippery surfaces. Because again, you want grip on slippery surfaces. You don't want snow chains. Okay? Now, it's already second generation is with the spray. It's even more convenient to use. Now, one of the classical examples also I like to show during presentations is this solution. Because I don't know if you probably, many of you already faced the problem of Scotch tapes, that you have to cut it and you can't get the scissors when you need it, or you break your teeth when to try and cut it, right? So let me ask you another question. If you, there's no cookies on the table or something, but how do you open the packaging of a Mars bar or a Snickers, or how do you open that?
A little cut in the top.
Yes. So it's V-shaped, so we always find a weak spot to tear it open. Well, that's a solution that exists probably for, I don't know, 30, 40 years within the packaging industry. Well, actually, it took so long before it has been transferred to the side of this Scotch tape that easily you can, if you don't have sweaty hands, you can easily tear it wherever you like. So you no longer need scissors or your teeth to actually have the tape cut. And then, okay, people tell me, yeah, it's a simple solution, it's easy. Yeah, yes, absolutely, but that's the benefit, or that's the strong thing about it. But it took 30, 40 years before this smart solution has been transferred from the packaging industry to the tape industry. Oh, voilà, that was that example. Okay, another application what you can do with this way of thinking is actually to solve problems. Now, I don't know, some of you had maybe in the beautiful breakfast buffet this morning, you had some cheese. And maybe you tried to cut it with the knife. And what is the problem? Or the inconvenience? It sticks to the knife, right? Very often, when you cut it, it sticks to the knife. Now, companies like Kraft Foods, etc., they had this problem or this challenge, let's say, on industrial scale when they cut it into little slices before going into packaging. Okay, so the goal was, or the challenge was, to increase the efficiency there to solve that challenge. And okay, first thing to do always, and it's something which is very often forgotten, is that first of all, it's interesting to look into the industry itself and to adjacent industries, like in this case meat processing, etc., to see whether there might be already a solution, if not within your company, maybe within your industry or adjacent industries. Okay, that's always the first step we apply. And then after we did that and didn't find satisfactory solutions, then we go out of domain. And in fact, what was the challenge here? Okay, it was about cheese, but what we tried to do here was to cut a sticky material. And there are other sticky materials in this world that need to be cut. So what were others? For example, rubber. And that's how we identified a technology developed by Goodyear. And actually it was patented, and the title of the patent was Method for Cutting Elastomeric Materials. Okay, so that's the way how we apply analogy to find and to compare different solutions, different industries with each other. And apparently this technology developed by Goodyear was a good solution for the craft challenge here. Okay, so that's a nice example, I believe, of cross-industry learning. And I have another interesting one. That was the goal here was to develop new, better, cheaper, more environmental friendly deodorants, the aerosol sprays. Now, to make a long story short, the top technology that came out to actually develop new, better solutions for deodorants, for aerosol deodorants, came out of the beer industry by Anheuser-Busch InBev. And they actually have developed a new technology for the disposable beer barrels for these home appliances, etc. Because with the metal barrels there was a whole supply chain issue and big challenge. And apparently that technology developed by AB InBev was a perfect solution also to make new, better, more environmental friendly, cheaper deodorants. Why is that? Where is the analogy? In fact, again, if you look in abstract to such a beer barrel or to a deodorant, in abstract it's two containers that contain liquid that needs to get out in one way or another, preferably under constant pressure, etc., etc. So again, it's very analog, it's very similar. And it's these kinds of connections that you should try to make to, again, not reinvent the wheel and have efficient problem solving. Okay, looking at the time, we'll make it for the break, don't worry. It's not about the 60 slides. A last domain of activity, or where you can apply this methodology, is to find new applications and new markets. Now, this is actually really a growing activity, and why is that? Because, okay, companies first want to sell what they already have, what they already know, what they already can produce. If you go to pure innovation, pure new product development, it's always higher risk-taking. And I have this nice example which shows the efficiency of the process. Now, this is about this material. I have a small sample here. It's a aluminium metal foam material. Okay, so the goal was to map all possible applications and markets for this material. Now, as explained, we won't talk about metal foam, but we'll define its DNA. So this material is transparent, it's scattering, it's porous, it's thermoconductive, it has a high surface area, etc., etc. So it has these set of properties, it's the DNA of this material. And as mentioned, these properties and combination of properties give you certain functions. And it's these functions that your customer, your client needs. Okay? For example, if we say that this material is thermal conductive and has a high surface area, that makes it a good heat exchanger. Okay? So you can have a look at who in the world is facing cooling challenges, and that's how this material now is applied for cooling LED lights, for example, in buildings, in cars as well. So applying LED lights in cars was an obvious move, let's say, but the cooling was a big challenge. That was a nice solution to that problem. Or like here, for example, we coated the oil circuits of a truck with a layer of this metal foam, and it gave enough cooling that they could nearly skip an entire cool engine out of the truck or the bus, which was, of course, a big advantage. So it's a very logical, structured way of thinking, let's say. And in total, for this specific material, we identified exactly 110 new possible applications. Of course, some are short term, but others are early stage. But let's say the ID pipeline was filled. So that brings me to my conclusion. So I also respected the timing. I'm happy, not always the case. But again, to summarize, please don't reinvent the wheel. Again, we continuously experience that's the case, and there's so many accessible, relevant knowledge outside your own domain from which you can certainly benefit. And that's probably why it's called research and development. And the search has already been done by somebody else. What you need to do is research it. Okay, it's in the name itself. And it's very important, again, to match really your domain-specific expertise, again, with that external knowledge from other domains, from other industries. And finally, I would say, yeah, maybe a little less talk, a little more action, and just do it. Thank you very much.
Thank you, Matthew. Thank you very much. Just, we have time before the break for some question. Yeah.
Oh, thank you. Nice talk. My name is Rolf Dimpelmann from Innolytics. I'm wondering, what are your major challenges to find new clients? I mean, they're all innovative companies and they think they might have the solution themselves. So what are your major challenges for this?
The major challenges are probably, first of all, the not invented here syndrome, as you all know. And we try to change that to the proudly found elsewhere. That's one of the major challenges. And also, you know, the internal company culture. To have an innovation culture inside the company, it's really difficult. You feel that every company, as you say, at least talks about innovation. But many companies still struggle how to have an efficient innovation and R&D process inside the company. And it's like you know, big boats that you need to change from direction. It takes time. And that's the issue. And you know, also companies, it's maybe strange to say, but companies are not made to innovate. Why is that? Because of the so-called performance engine. People put everything in good, efficient processes, try to optimize things. Once everything gets rolling, please don't touch it because it works well, and don't change it. And that's the difficulty. And really, the last thing I would say about that is that companies really should apply this open innovation way of thinking, and not doing everything themselves anymore, but really building bridges, talking to research centers, to even competitors, to suppliers, etc., and apply this open innovation network. And as I say, it's really an accelerator for innovation. But there's still a nice long way to go.
My name is Osama Musa from Ashland, United States. Very good talk. The question for you put some like over 15 clients, like
Yes.
all chemical companies and other companies. What is the rate of success? Like you have like all the examples that you showed, like an old examples, which is great for that. But anything like recently or things from all these clients? What's the rate of success from what the problems that you received and how you solved them?
Yes, very interesting question, which always comes back. It's 200%. No, it's very high. It's very high. I would say we won't pretend to say that we can solve any given challenge very fast without big investments and find the perfect solution. Not at all. But I can really assure you that each time there are at least new things coming out of it, which open new directions, but we certainly won't pretend that we can solve any given problem from today to tomorrow. But it really it's kind of structured logic that we apply, and we always say that we are not smart, but the whole world is very smart, and that's what we try to benefit from.
One more question.
Yes, hello, Hendrik Wageman from the Biobased Europe pilot plant in Belgium. We're an open innovation pilot plant that tries to scale up processes from lab scale to industrial scale. So we work for a number of companies, small companies, big companies. What I've seen is that especially the big companies, they are very reluctant to any kind of open innovation, not being afraid that their innovation would be like transferred to other companies, but especially afraid that we would use knowledge of other companies that would bring them into trouble. How do you see this? I think the chemical industry is a bit of a conservative industry. You've given some nice examples of other industries, but how do you think this will evolve in the chemical industry in the next years?
Well, it's how would I say? Every industry always mentions that we are very conservative and we are not very open, and we have lots of limitations and lots of legislation to take care of, etc., etc. There again, everybody tells the same story, and it's not different in the chemistry, in my opinion, and not different in the chemistry than in other industries. But again, it's still that open innovation way of thinking. It's getting there, but still it's still early stage, and there's still lots of work to do, and lots of mindset that need to be changed. And as I was mentioning, the innovation culture inside companies need to change. But it's not different for chemistry, in my opinion, experience. Not different for chemistry than for other industries.